And now I'm going to try to establish a workshop for all McEwen Lab members who are interested in data analysis so that everyone at least has the most basic platform off of which they can develop a practice in R programming and data analysis. This is called How to Start Doing Things in the R Programming Language, and that's based on a very inspirational thing I heard from one of the students in the lab recently who just typed that into Google, how to start doing things in R. They just hit go. It's very, very awesome thing to type into Google, and inspired me to write this. So first, there's been a data revolution in biology over the last decade. It's been particularly impactful in the field of ecology. The ESA, Ecological Society meeting in 2020 was titled Harnessing the Ecological Data Revolution. So that's a couple of years old now even. And, you know, that's a little bit behind the curve probably. So there's been this ongoing revolution for at least a decade, I would say. McEwen Lab members need data skills. If you're going to be in ecology, this is a research lab. We use R in the lab, and if you're going to be a researcher in the field, you need to use R. In fact, the Ecological Society describes basic training in environmental biology as including quantitative reasoning, and they literally list R. So it's something you should get in classes. I can say I've been developing that in our curriculum at the University of Dayton, but also we need to have a more formal approach in the lab as well. What is R referring to? R is referring to the R Project for Statistical Computing. This is a program that is freely available online. Again, it's a decade or more old, and folks have been developing this and redeveloping and developing packages for it for a long time. It's part of a community of data scientists or who are dedicated to R and R training. There are almost endless resources online in terms of how to do R. So it's really a wonderful development. And in fact, it's becoming more and more popular. This is a paper from a few years ago. In 10%, in 2008, when I came to the University of Dayton, 10% of papers in ecology cited R as the data statistical package they were using. By the year 2017, that was 60%, and it's only going up. So it's just like every year, more and more people who do data analysis for publishing use the package R. It's gaining popularity rapidly. Many graduate programs want students to have R experience, and in fact, many employers now like students to have that skill. So this is something for you to, some skills for you to gain. So why is it so popular? This is what I would say. This is what I do say about it. I call this in our lab, folks need to adopt this philosophy. It's an egalitarian sandbox. Egalitarian means it's free, just available for anyone. Anyone can use R. You don't have to have any special training, actually. You can start utterly from scratch, and it's online as long as you have a computer of some kind. You can't do it on your phone, but basically any other kind of computer you can use R. You can just download it. And there's also a huge network of online users that can help you with issues. You don't even really need to buy a book or anything. You can go to a thing called Stack Overflow or other things. Are literally like the student did, just type into Google how to create a graph in R, and you'll get 17,000 hits within a millisecond or something. Sandbox is just that you can do whatever you want with it. One of the things about R that we have to just dedicate ourselves to is this idea that you can do any particular thing many different ways. And what I'll show you in the lab and even in this little exercise is only one way of many, okay? It was designed that way with that in mind. It's the whole point of it kind of is that you can create your own path and mechanism and procedure. I will say that some people develop very rigid processes and can get kind of closed-minded about it, actually, just like this is the way you do it. But those people are just wrong. I mean, if you encounter someone like that, like your future PI or something, like this is the way we use R, and our we download these packages, we run it this way. Your, as a McEwen Lab member, your solemn obligation is to just be like, oh, cool, that's great. I'm so pleased to learn this process, but never adopt that rigid perspective. You don't want to, that's fragile. You want to be like water, as Bruce Lee said. Just be like water. You have to let it flow over you. Learn everything you can, but never become rigid. That's the idea. Okay, so it's a sandbox. You can go any direction you want with this. You can head north, south, east, or west, and develop your own processes and practices. So it can be really enjoyable, actually. It can be a little bit of habit forming almost. Okay, so how do you start using R? Well, the first thing you need to do is download the software. And so you can go to this www.rproject.org, and you'll see a page like this. Your internet users on a daily basis, you can find it. It's not very hard. There'll be different versions. The versions are very cute, have cute names, like this one's called Dark and Stormy Night. This one's called Great Truth. One I have just now is called Kicking Things or something. The best one was, there's something about Pumpkin Patch a while back. I really liked it. Anyway, they put goofy names on there as they update it slightly. And anyway, you're just gonna hit download R. When you hit download R, you're gonna have to select what's called a crayon mirror. I would have a hard time explaining it to you, and probably because I don't fully get it myself, what exactly this means. It's irrelevant. Just pick one that's close by. You can pick Indiana University. I oftentimes pick Case Western just because it's in Ohio, which is a goofy thing. What? But I just do it that way. I don't know. Some kind of loyalty to the state or something. But whatever. Pick the one that's closest to you. Or I wouldn't pick one far away, like Dallas, Texas, but the one in Indiana should be perfectly fine. That's from where the packages and stuff will download onto your computer. Then you can pick the kind you want, or the version you want. I use Windows. A lot of people use Mac. Some people use Linux. It's fine. Whatever you want, whatever you like, just download it. And then you'll want to install R for the first time. It might dump into like a little tray in your browser. If it does that, you just gotta go look in that tray and find it. It's like a little download arrow thing at the top. And then maybe I'll show you in here in a second where you might find it. Just drag that over to your desktop and run it, the exe file. I think that's what it is, .exe. And then it'll install, it'll unpack. You just say yes, 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 yes. Just agree to whatever. Just do the normal stuff. You don't need to do anything special. Just follow along whatever recommendations they're making. There you go. You download R. You get an exe thing like this. You run it. Oh, there it goes on your desktop. Isn't that great? It appears like this on top of the desktop. If you say put an icon, you might as well just say that, put an icon. Yep. Great. Now you can run it like this if you want. This was called Lost Library Book. This is another good one I used to have. Anyway, actually R is, it doesn't need anything. You can run it just like that. And I've done that for a long time. However, it turns out that a lot of people like using a second package called RStudio. RStudio is very popular. So I'm going to teach you how to use RStudio. And I'm going to do that from now on in my classes and stuff too. Personally, I find it a little annoying. I don't see how it helps. But that's just because I'm old. Maybe. Or I don't know. I don't know why. But I don't see what the point. But here's the thing. A lot of people like it. In fact, if you move to some university and you've got a new PI, especially if they're younger than me, they'll probably use R and RStudio. So it's like, it's a standard operating procedure at this point. So we're just going to roll with that. Again, remember the thing I said about being rigid? That's the key thing you got to reject. We're not going to be rigid. That means you, PS, 10 years from now, when when people are like, RStudio is a piece of garbage, you need to use R Flamenco or something. You just got to be like, all right, man, that's fine. Whatever. Don't care. You don't get rigid. So here's RStudio. So you go to rstudio.com like that. and you're going to download it. See this little arrow right here? Just go to Google and type in RStudio. It's not hard to find. You'll find it. Your internet users, you'll find it instantly. Just download it. It'll give you a chance to go to this thing. Or you can pay, if you want to pay $5,000, you can. I won't stop you. I don't understand the point of that. You can just get it for free. That's what I would recommend. I think if you started to work for NASA or something, then you would give $5,000, maybe, or something. It's like, if my data are wrong, this shuttle crashes into the moon. It's like, okay, maybe level up. But if you're just doing data analysis like we're going to be doing, RStudio desktop for free is perfectly fine. So once you download that, it's going to do the same thing, the exe, and it's going to pop up like this on your desktop, and then you've got friends forever right there side by side. It's a bromance. That's what it is. Okay. Now, you have a system for data analysis. This is awesome. You've got RStudio and R. R is the engine. RStudio is basically the controls. That's all it does, actually. All RStudio does is take the R program and be like, okay, let me just simplify this for you, put things into place, make it easier. That's what it does. It's really more of just like a control panel. So anyway, you've got RStudio and R on your computer now. So that's just great. Dandy. You're ready to do something. Now you're ready to start doing things in the R programming language. Good. So get all that done. Maybe pause the video now. That's a good chance to pause the video. Because the next thing we're going to do, are you back? The next thing we're going to do is, let's just minimize this, is take a look at what RStudio itself looks like. So here it is, it's on my desktop, RStudio, you see that? I actually have a double screen. Oh, I don't have the R, here it is, okay, there we go. They should be close together. They can nap together, like I have two cats that's like to lay together, nap, so. There we go. Now, got them both on your desktop. To open RStudio, you don't need to open R. RStudio will open R. That's how this works. When you open RStudio, it looks like this. So this basically bit over here is what's called the console, and that's telling you like, oh, here's the name of the package you've got. Kick things, which is the one I've got now. Over here, this little bit over here is for plotting. This is like when you make a graph. And this is the sort of environment quadrant or something like that. I don't really use this. There's probably a lot of good stuff there. I mean, what you'll find with R and RStudio, if you work in data analysis for the rest of your life, every day, all day, you're not going to touch a fifth, now less than that, a tenth, maybe 7% of the total of R. There's like hundreds of thousands of packages in R. So in RStudio, still, even just RStudio, there's like way more stuff. Maybe if you stayed at it for a decade, you'd be like, I know every single thing on it, how everything works. But for the purposes of just like getting started in R, doing a master's thesis or whatever, using it for your data analysis, you don't have to learn all these things. Just like develop a process and workflow that works for you. So we're not going to dig into every single one of these things, like connections. I don't know what that is actually. See over here? I don't know what that is. Okay, anyway, so you've got the console, you've got this environment quadrant, and you've got the plot thing down here. See this? This is my cursor. So what we're going to do is go to File. We're going to work in scripts. I know that some people use Markdown, but we're just going to work in scripts, partly because as of right now, at least in our university, in our department, the other faculty don't use Markdown. They all use script. And so this is also going to wash over us maybe in the future, and everybody else not use script, so use Markdown. I have no idea what's going to happen. But this is the standard operating procedure. Again, I don't even, if it was up to me, I wouldn't even use Studio. So much less Markdown. But anyway, I'm going with the flow. And the flow right now is use RStudio and scripts. So that's the way we're going to do it. This when you open, you say File, New File, R Script. See that? File, New File, R Script. When you do that, it pops up here, and then you really do have like quadrants. Since I don't really use this environment quadrant, what I usually do is just grab this and pull it up. Maybe somebody knows more about this connections and tutorial, whatever, but I don't use that. And so you got the flashing cursor up here. This is where you're going to start typing in code. You're going to start to do code. Now, the next thing to say, and this is where the coding is going to get going to be input right here. And you can save this. And that brings me to the next point, which is you need to start developing a plan for how you're going to store your data and how you're going to store your script. And what's the plan for that? And so you need to establish a folder somewhere on your computer, on your desktop, or in your documents, or if you use Google Drive, and there somewhere that you can map to, and then you know where it is, and then like come up with a really good plan, especially if you're going to seriously do research. If you're going to be like, I'm going to be a master's student, or much less a doctoral student. Remember my shifting gears in science careers. If you get like into second gear, you need to start getting very serious about file management. It needs to be kind of an obsession, because you'll end up losing your files if you don't do that. You have to be pretty much a zealot on that one. So this is your first chance to do that. So think very carefully about where you want to store your stuff. And then once you do that, wherever that is, I'm going to give you a data set, and you're going to put the data set into your file. So here's my, I use Google Drive for all my stuff. So, and this is using this Windows Explorer. Do you know about that down here? So there's this thing called Windows Explorer. I don't know if it's the same in Apple, probably. Is it called Apple? I don't know. Macintosh, whatever that is. Anyway, go to, so here's where I store my stuff, my drive, R, and then I've got a bunch of R things, lab, data, for example. This is a place to find the data that I'm going to use for lab. You have to figure out where you're going to put it. So you need to know where that is. And we're going to use this little data set here called tree data. And let me just talk to you about it for a second. So I got two screens, a little awkward. Here we go. Tree data. Now, here's the other thing that you need to know, some other things you need to know about R. I've got to if you take my class in the spring, I'll talk about this for weeks. So this is like going to be the thumbnail of a tip of an iceberg or something. The one grain on the tip of the iceberg. Maybe that's a better metaphor. Anyway, okay, data in a spreadsheet. Big topic. To summarize, they can't have a bunch of bullshit. You can't have like all like the data going every direction, all kinds of tabs, things. It has to be very clean, carefully organized. You know exactly what everything is. Again, this is where you have to become a bit of a zealot. Now, you may have Excel sheets where you've got like a whole bunch of notes and stuff. That's okay. But when it comes time to do analysis, it has to be clean and crystalline perfection. If you don't have it clean and crystalline perfection, then your data analysis won't work. It won't load into R correctly. If it comes in, it might not come in at all. If it does come in to the package, it's going to give you ridiculous results and not work. So you need to take the time to stop and get the data clean. So this is an extremely clean data set. There's no bullshit here. Everything is in the corner. There's no spaces, random stuff. There's no formulas. It's just like, this is the exact data. We've got column headings, and then we've got values. It's it. So, and the other thing to know about data and R is that you're going to save, at least you're going to save the file as a .csv file format. The way you do that is go File, Save As, pick whatever folder it is. See this little drop down right here, Save As Type, CSV. Get right there, comma limited. My guess is maybe even with RStudio, you could load it in as an Excel workbook. I'm not sure. I did try that the other day. It didn't seem to work. The standard for R is CSV. In fact, the standard for anyone serious about data is CSV. The CSV format is more stable. It's not subject to proprietary software issues. It is the file format of choice. Okay, so I'm going to give you the data, tree data.csv. You're going to find a place to store it. And this place that you know where it is. Don't mess with the data because it's already going to be clean. Just save it somewhere. Okay. Good to go. Now, okay, I'm just closing all this up. All right, so now we're gonna start doing some coding. Before we do anything, though, I'm going to ask you to install a couple of packages. Packages are just, I'm going to ask you to install a package. Packages is just where some clever person was like, oh, you know what, I'm going to take all this R code and build infrastructure out of it. And so it's sort of shortcuts, basically, the code. Or like organizes the code in a different way. And this particular person, I think his name is Hadley Wickham, designed a package called ggplot, which is a very popular graphing package. Similar to RStudio. Personally, I find it a bit irritating, and I don't, it's like, whatever. However, the fact is, it's very, very popular. It's skyrocketing in popularity. And it's gotten to the point, actually, where some people kind of think ggplot is literally the only way to graph things. That will wash over the field in a couple of years, probably. I already hear people talking about Python and Plotly and all this other stuff, but it's like the de jure graphing package. And because it's the de jure graphing package, I need to teach you how to use it until such time comes when something else washes across us and we just go with the flow. Wherever we're going, we're going. Anyway, there's a whole thing called the tidyverse, and ggplot is part of that. So we're just going to install tidyverse. And the way you do that, you type in these words. I pasted them in because I got some code elsewhere, but you could literally just type. When you go over here in this flashing cursor, you literally see my little fingers. You just literally start typing. You can install .packages and then tidyverse, like that. You just type it in. I pasted it from somewhere else. And so then you're going to highlight it. And there's a little thing called here, a little thing called run right here, a little button. It just runs it. You can also use Control and Enter to run the package. When you hit go, it'll start to do stuff down here. I already have it installed, actually, so it's kind of yelling at me. When you get red stuff, it's sort of yelling at you. But don't worry too much about it. It'll take a little bit longer. Mine just, you see down here, it just popped up in your console. When you do stuff up here, the script shows up. What you're doing is kind of like R is replying to you in the console. And so when you install a package, it shows up down here like that. Or it'll run down here and stuff will happen. So whenever you type this in and you hit go, it's going to, like, things are going to be happening. And then we're going to, once you've got it installed, you activate it by saying library tidyverse like this. Again, you just pasted this in, but you would just literally type it in. Library tidyverse like that. And then hit run. That just turns it on. So also, I should say, look, here's some action down here. I also should say that generally speaking with R, you're going to be typing code and errors are common. In fact, I've been teaching R for 10 years and make errors almost every single line. And sometimes it's just the stupidest, simplest error. I just can't. Um, it's like, oh, I just didn't put a comma or something. Almost every line of code I type, I mess up something almost. And then you just have to fix it and run it. One thing you should not do in your mind is think like, oh, I'm going to type this code out and it's going to be perfect. It's going to work every time. It's just not true. And if you get to the point where you like run it and it doesn't work, you can't start to think R is broken. That's not true. Ours, there's thousands of people are using it at that moment in time somewhere else successfully. It's going to be user error. You might sometimes glitch a little bit. You might need to restart it and like, or run some code up above where you are. So I'm not saying that it's flawless, but generally speaking, it's a very durable, stable tool that people use all the time. It's probably not that R is broken. It's probably that there's a comma missing or you spelled the name wrong. You've got it. All the stuff has to be correct. And one good thing about RStudio is if you have your code typed out here, a little X will come up. It's like a problem. If RStudio thinks you've messed up, it'll still tell you. Even still, it's just. I'm just trying to say you can't. Don't overreact if it doesn't work right. Just stay with it. Search for errors, and normally you can figure it out. So even like installing the library or whatever, it might mess up. Now, the next thing you need to do is read in the data. Now, the way there's two different ways to do this. One is to use this import dataset tab right here. See this in the environment? You can go import. This is probably the easiest way to do it. So let's just do it this way. From text, and then wherever you put it, remember earlier I told you better be careful and put it in it. Sure. So I'm just like scrolling and through all the stuff to find where the data are. It'll come up like this, and you say import. Here come the data. It's great. That's one way to do it. You might also, and I was taught this thing called the read.csv command, which looks like this. I'm going to paste it in, but and I'll leave this here. You're going to name the file like this. Tree equals read.csv, and then this is the path where the file was found. So for example, and not very many people do that. I mean, this is like sort of old school, but in my case, it's my drive, R, lab, data, and the name. So that's what this is. It's just a drive path. And so then you can run this. And when you do that, it names it tree. I think because I imported the other data set this way, tree data up here would be what it's called if you're when you start to call in the code. So depending on how you do it, I should have named it probably the same thing here. I'll do it this way. There we go. All good. So yeah. So this is the read.csv command, or you can use this environment import data set to get the data in. Now, once you have the data in your read it in, the good thing to do is read it like this. Read data, highlight it, and run. It should show up in your console down here. See this? I just moved it up. This is a console, and here's the data set. Also, if you've read it in using import data set, it would appear here. It looks kind of organized like an Excel sheet or something. Okay. That's like now you're starting to code in R. Exciting. Okay, so now we're going to create a graph. That's going to be our first action here. So we're going to use ggplot, as I mentioned. So you're going to type ggplot. Ggplot is like basically commanding R to make a ggplot. And then you go, okay, I'm going to make some bracket, and then you're going to call the name of the data set, which is tree data. Comma, AES. AES is like aesthetic mapping. This is the guy who came up with ggplot has got this whole philosophy. There's a book like The Philosophy of Graphing. It's very deep. Anyway, AES is like this aesthetic mapping idea. Don't worry about it. It doesn't matter. Just put a comma and put AES. And then the next thing you're going to do is you're going to tell R what you want it to graph. Tell ggplot, this is what I want you to graph. And what we're going to do first is we're going to create a graph. And this is actually, I'll share the figure with you from an actual published paper. And we're going to work with data. This tree data is from an actual published paper. I'll share it with you. What I'm doing here, you don't have to think about or worry about it all. It's from this paper. And we're going to look at, we're going to create, let's see. Basically, we're going to be working with the data set that's in this figure. Again, I'll share this with you. And so we're going to be working with percentage of the stem wounded and wound length on here. I think that's what, oh no, we're going to work with sample diameter at wounding and percentage of the length, percentage of the stem wounded right here. So it's going to be these two data sets. And we have two eras, historical, see this? Historical and prescribed, those are the eras. And then this is the y-axis, see my cursor? This is the x-axis. And so what we need to do back in our, so this is already a published paper, but what we're gonna, here's RStudio down here. What we're gonna do in RStudio is, with ggplot is say, okay, here's what I want you to put on the y-axis. And we're gonna start with percentage, right here's percentage. And we're gonna go y equals percentage. And make sure it's capital P, otherwise it'll be confused. And then X equals era, because that's what's going to be on the X-axis, the horizontal axis. So that's telling ggplot that this is, I want you to make a plot, create an aesthetic figure, and this is going to be X, and this is going to be Y. Now, we got to give it more detail, and the way we're going to give it more detail is a little plus here. Depending on how you're coding graphs, it's different connectors, but for ggplot, there's pluses. Okay, and I like to tab after the plus. That's just my style because it makes it clearer to me. And we're going to go geom box plot. That's just saying, hey, make a box plot. Box plot is a kind of graph, and then you have to close in this brackets. There would be a lot of stuff, but you don't need anything for now. We're just going to make the most basic possible box plot. There it comes. So you can see it over here in this plot quadrant. So what is a box plot is a long topic. I can't give it to you and just like introducing you to R. So we'll have to just stay tuned and also maybe take my class, like I said before. It's a kind of way of portraying data when you're comparing groups. And so here we've got historical and modern, and this is percentage. We would have to change the, we could change the Y label. You can change every single thing about this, the aesthetic of this graph. But for now, we're just gonna roll with what's in the data set. But this is the same thing as this figure. Percentage of the stem wounded, historical and prescribed, okay? Historical. Prescribed is the same thing as modern. In this case, so it's a little bit different, but it's the same thing. So if you go back and be like, okay, this is taller and this is shorter. The box plot gives a lot kind of different information. It gives you actually a lot more information. It gives you a sense of the range of the data instead of like a bar chart, which is what I used in this graph and this paper. It's just giving you the top of the bar as the mean, and then gives you a little sense of error here. I think this is a good looking graph just to say, but in terms of the information display, it's much inferior to this. This is way more information presented. So anyway, this is the figure. And you can see this one's a little bit taller than this one. This black line here is the median. The median for historical is quite a bit higher than the median for modern. And that's a box plot. So this is, see if you can type this in and get this to work. Pause the video, type the code. Okay, so Now, the next thing I want to show you is this is just like a different kind of graph that I want you to, very first time you graph something, I want you to go ahead and do it this way. This is called geom jitter. Jitter. We'll call this a jitter plot. Got to put a plus there. Remember, a geom jitter. So we're going to make a jitter plot, and the jitter plot is going to show us all of the sample size. It's going to show us the data like this. So this is kind of a mess. It looks like the figures have a rash. We're going to clean this up a little bit in a second. But the point of it, this is like the simplest possible way to display the data in this fashion. The point of this is every single one of these is one of the samples. By the way, in this console, you can see every one of these is, each of these is a sample. Now, the reason why you want to go immediately to do this, what we'll call a jitter plot, is overlay it on the box plot, is it gives you an idea of the distribution of the data and the sample size. One thing that mistake people make is running analyses without really understanding whether the analysis makes sense. In this case, we can have a sense of like how many, if there's three versus two, if we're comparing two groups and there's only that many, versus in this case, we've got so many, I can't quickly count them. There's like more than 30 in each case. We've got a sense of how many are in each group, a sense of the range. We do have this one outlier right there in the modern, but otherwise they're pretty much contracted down below most of the data in this, which is demonstrated in the box plot as well, but it just gives you a better idea of what's happening. Now we can clean this up a little bit. I'm going to show you how to clean it up. Let's type this word position equals position, did I spell right? Position underscore jitter. Jitter is like shaking the points basically. We're going to make them be a little bit tighter like that. If you do that, it's going to pull it in a little bit. Like this. It's a little bit cleaner. We can just roll with it like that. This is a pretty good look at the data. So now you've got a kind of an idea what's happening. And then what I want you to do is copy and paste this. And there's lots, by the way, this is, as I said, tip of the iceberg. We can change every feature of this graph. But this is a pretty nice look at what's happening with the data set here. Then I just copied and pasted this down here because we're just going to change the y-axis and also look at the other variable. The other variable is diameter. Diameter in this case is the stem diameter. Diameter. You can just copy and paste it. You don't need to type all that stuff in again. It should run just fine. You just paste it down there as long as you spelled it correctly. Yeah, it just runs again just like this. This gives again a good idea of what's happening, and now we can actually toggle back and forth using these arrows. This is a helpful feature of RStudio. Actually, I like this. You can go back and forth easily. See this little arrow right here? Okay. Diameter of the stems. This is trees. For historical, this is fire scars. Okay. The diameter and each one of these points is a tree. That's the sample size. The diameter, or this whole thing is a sample size. Each of these is a sample. The diameter of the trees who are receiving historical fire scars, median diameter, we don't have the labels, but let's leave this all alone. It's just for now, is much lower. This is almost 40. This is less than 20. This is like more like 17. This is much smaller. And in fact, a lot of the data for modern, at least points up here, and the median for modern is almost above the most extreme value for historical. This is like pretty good evidence that diameters in modern trees for fire scarred trees is larger. So that's just like how you would interpret this. You can switch back and forth to go, okay, this is percentage of the stem wounded. Percentage of the stem wounded in historical fires is, again, median here is almost above all the range except for this one outlier. This is, again, really good evidence that the percentage of stem wounded in historical fires is higher. Again, we'll have to run a statistical test, and there's a long way to go to get from here to this figure that I showed you before, which is like, what's the p-value? Oh, p equals less than 0.01 in both cases. You can go back and look at this. I'll share this with you. This is very nicely, by the way. This is a very nice looking figure, but I'm not a fan of bar plots. That's 2007, so it's been a long time. Even at that time, I knew I should put a box plot. Anyway, here you go. If you've done that, you've created a graph in R that's a really sophisticated approach to looking at data. Now, we're going to do one more thing. So I can show you just one, and again, we can change all these different features. But I'm going to show you one more kind of graph because I think it's useful. We're going to do, okay, here we go. ggplot, again, free data. So we're going to use the same data set, comma, AES. It's going to go y equals percentage, comma, x equals diameter. Okay. So now we're going to graph these two instead of using era. So let's look at this console. Instead of separating these into eras and comparing two groups, we're going to compare the relationship between these two. In fact, if you toggle back and forth between these, you go, okay, maybe there is a relationship between diameter and percentage. That is to say, larger diameter stems have smaller percentage of the stem wounded. It's a reasonable thing to think about and want to take a look at. So we're going to make a scatter plot. And again, you have to put this plus, and so that's why we have the beginning is the same thing. ggplot, free data, it's pointing to the data set. AES is like make an aesthetic map, basically, by X, and then plus, again, I like to tab here. We're going to put geom underscore point, POINT, geom point. Again, we can do a lot of different, this is just like the start of what we can do. Percentage, I must have spelled this wrong. It wasn't, this is a good example. It wasn't capitalized. See down here, she yelled at me. Hey, this is not a thing. I told you, every line of code I've ever run is, even more messed up. Okay, I pause. Here we go, hold on. That's good. Did pause for a second. I don't know what the problem was, to be honest. It's good. Yeah, so there we go. So this is the, again, almost every code every single line of code I write is a mistake. So just how it goes. Anyway, here we go. This is what I wanted to show you. Percentage and diameter. Oops, I've got these flipped actually. I want x-axis to be diameter and the y to be percentage. There we go. Yep. So yeah, this is the figure I was trying to get you to create. See if you can get this to work. Again, I had a little hiccup there for a minute. See these red things? I don't know. I think it was fine. If you put this code in, just type that in, it's going to run just perfectly fine. So this is like diameter and percentage. And this idea is just like, as the stem gets bigger, the percentage of the stem wounded gets smaller. And we can actually push a line through this. This is kind of a cool thing to do. This is called stat smooth. method equals LM is a linear model. I'm gonna, if you just run it like this, yeah, let's just run it like this, see if this works. It's gonna go like that. This is pretty dynamic. I don't like this because it's actually projecting, this line pushes down below 0, which doesn't make a lot of sense. So but we could leave it like this. The other thing to do would be put a Y limit in it like this. Y lim, and this is 0, 75, close comma. So that's just putting a Y limit in the graph. Watch what happens. See if this works. Let's see. I screwed up. No, it looks okay. But now our 95% confidence interval here is kind of messed up. So we can turn that off like this, comma, SE equals false. Like that. Oh, again, some kind of error. Oh, I didn't close it. I didn't close it. Yep. Coding mistake. Okay. So, yeah, there you go. So I think if you just maybe skip through all those mistakes and just come to this, that'll give you an idea of what the of what a graph like this can look like. This is just a scatter plot with a line through it. You can do lots of analysis to find out what the strength of the line is and so forth. That's a different issue. So we can sweep the plots by doing this. See this little broom? Clear all plots. And then we could run them all together. Here's a box plot. Oh, okay. Percentage is higher in historical stems or historical fires. Oh, diameter is bigger in modern fires. But if we just toggle back and forth, it makes you go, well, maybe percentage and diameter are related. Okay, let's just run this analysis. And you saw me clean it up with this YLAM and stuff. I don't know what I would do in the paper. This is not in the paper, this analysis. But anyway, there you go. This is how you do a scattergram with a regression line. So that's like just getting started in R. There's a few hiccups along the way, but I think that's probably better, actually. This is just this tiny bit of code here. I can actually just send this as an email because it's so minimal. And hopefully this was helpful for you to get started. If you can get this done, then you can start to play with it and toy around. And I would definitely urge you to use Google and just, if you start to, it's like, how do you plot a scatter diagram in ggplot, and see if there's other ways people are doing this, or how they're changing or adding different points or changing the colors, or just like having fun with it a little bit. And we'll see you in lab.